Okay, we're good to go.
Hello, everybody. I'm very pleased to present Gérard Assayag, who will be talking about co-creativity and symbolic interaction. So Gérard is head of the IRCAM music representation team and has also been the head of the IRCAM research lab. You may know him from popular music research software environments for computer-assisted composition, analysis, and improvisation, such as OpenMusic and Omax. Assayag's research interests are centered around music representation, programming languages, machine learning, constraint and visual programming, and computer-assisted composition and interaction, just to name a few. Today, Gérard will be sharing some of his work on co-creativity and symbolic interaction. I'll leave the word to Gérard.
Oh, thank you, Doreen. So, hi, everybody. So, as Doreen said, I'm working at IRCAM, which is a fancy place where we have musicians and researchers and technicians. And I'm head of a team called Music Representation, where we've been working on many things, including computer-assisted composition. Here you can see the OpenMusic software. A few books have been written relating the composer's experience with. It's a visual with OpenMusic. It's a visual programming environment for composition. And this is the structure of the team right now. So where you see the green arrow is what I'm going to talk about today. So it's just one of the projects in the team. But as you see, we have projects on formalization, time and interaction, AI, machine learning. And the reach is really the co-creativity stuff, where we have interaction between human and live software agents. So here's an example of OpenMusic. Where you can see that you can control compositionally not only the scores, but also the sound and the space. And here's another example of a very prototypal version of OpenMusic, where it connects to the agent and interaction stuff. And you're going to see agents that pop up on the screen that are created dynamically in order to be able to give an answer to a music line. So you see, it's really right in the middle between offline composition and real-time interaction. So this was the state of research in the team before we began the co-creativity stuff. And we began years ago by designing a software called Omax. And actually, it's more than a software. It's a paradigm of improvisation with a computer where you have the loop, listen, that is try to have some artificial listening model, learn, that is try to do some machine learning, model, that is create a model, a memory model of the music, and then generate, and it's a loop that happens in interaction with the live musician. As you can see on this slide, Omax has been successful and has inspired many, many works at IRCAM and outside IRCAM. So the Omax model, as I say, is listen, learn, and generate. And as you can see here, this is a graphical representation of the memory as it is built in real time by Omax by listening to musicians. So as you can see on this slide, Omax is a kind of reification of what I call the virtual past. That is what's happening in the head, what's supposedly happening in the head of a human improviser, where the improviser is listening to the musical context, that is maybe other musician, but also self-listening, listening to what he or she is producing. And also the musician has a memory with all his musical background and experience and knowledge. And all this merge and derive in memory in time, because time is passing, and derive in memory by forming virtual images that are then reinjected in the process, being transformed and recombined, because memory is tricky. And this is one of the issue of improvisation, is that as memory is tricky, it's also creative. So actually the software tried to simulate this mechanism by putting in the material world, in the sound world, and giving sound feedback to the performer. So under the hood, Omax uses a formal model called the factor oracle, which is a linear automaton that is very efficiently models the structure of recurrence in musical sequences, and is able to do this in real time by just listening to the musician. Here you can see as an example for a work that was conducted by Assayag and Shomo Dudneuf using the factor oracle, where you have the Beethoven's first piano sonata played by Goulda. That's a very noisy recording. But the system is still able to build up this representation and to recognize all the parts and the thematics, the thematic cells in this piece. So actually, what we have is like a sparse correlation matrix that is built very efficiently on the fly. So it creates recurrences, arrows between recurrences, and then the model is able to navigate between recurrences and thus recreate a statistically similar message. So here's an example where we use Omax with audio, not only audio, but also with video. Actually, the video is following the audio. So this is the famous free improvisation by Jimi Hendrix at the Woodstock Festival. And it's totally recreated on the fly after a phase of learning, of course. But then it's recreated in real time on the fly by recombining not only the audio, but also the image. You can even hear some polyphony because we instantiate several Omax agents able to simulate this improvisation to reconstruct, to simulate and reconstruct this improvisation by Hendrix. Here's another live interaction between pianist Bernard Lubat and the Omax software in a very different style. Okay, so Omax was kind of the prehistory of the co-creativity project, and it was followed by the project called DICE2, that is Creative Dynamics of Improvised Interaction. That was a national grant from a National Research Agency. And we were trying to extend the Omax paradigm. So you see, we have this loop between listening, learning, and interaction, where the interaction is fed not only by the model obtained by learning, but also by the real-time sound context. So we were hoping to have to increase Omax with some reactivity to the context, because the standard Omax doesn't react to the context, it just plays. And to also increase Omax with some planning capacities, thus getting closer to what a human musician, a human improviser does. So we came up with some very interesting theoretical results. For instance, we came up with a Bayesian graphical model where we have several agents that are represented by the states of the model who can play together and co-invent a melodic line and a harmonic line. So each agent is informed by a probabilistic model where you know that such chords can follow such chords, or such chord can follow such notes, etc., etc. And one is specialized in melody, one specialized in harmony, and each agent is building at each step a prediction using the belief propagation algorithm of the marginal probability of what's going to happen, and then makes a draw. And so the melody and the harmony are really co-invented. So here's a very simple example here, where, oops, it's here, okay, where the system was trained on the famous jazz standard anthropology, and you will hear a variation of the harmony and the variation of the melody that are built step by step by two agents that are kind of discovering together the future. So it's not great music, but it's very interesting because for the first time we're out of the classical scheme, giving a melody, try to find an accompaniment, giving an accompaniment, try to find melody. It's really co-creating a new situation where things are discovered on the fly. Okay, so this is for the theoretical models, but then we want as I said, we are trying to expand the Omax paradigm to planning and reacting. So the planning stuff is on the left and the reacting stuff is on the right. So the new model, planning model was called Improtech, and reactive model was called Somax. So in the planning stuff, we have a scenario. So a scenario is just a sequence of labels in any language that you can define. And we have a memory where the states are actually pairs with one label and some arbitrary musical content. So the system is following the scenario label and trying to query the memory to find to navigate the memory and find good trajectories in the memories that will match the labels and generate new content. And of course, you could have reaction to the context, and then there will be a new query that will kind of reconsider the anticipation in the future. So if it happens fast enough, you will be able to recompute the future before it happens and then adapt to the environment. In Somax, we have an input, and you have many musical stream views that is musical dimensions such as pitch, chroma, loudness, etc. And every time we have a pattern appearing in the live input, wherever this pattern is recognized in the memory, we have Gaussian peaks, as you see here, continuous Gaussian peaks that will configure, that will construct profiles and combine together linearly in order to build up complex profiles in this memory. And these profiles will become hotspots, that is, places where the system will be allowed to jump because it matches actually the context. So it's going to be reactive. And additionally, when you have a peak that appears at some time in the memory, it will continue to exist, but shifting in time and decreasing exponentially. So this will account for fuzzy pattern recognition, because look here, if for instance you have ABC coming in the memory, so all the A will be highlighted. Then if you have a B coming, all the B in the memory will be highlighted, but the A will be shifted, and then it would add up to the B and make a very big prominent peak, which means that the pattern AB is recognized. And this is fuzzy because you can see that here, of course, ABC will be recognized, but also DBC, also ADC, also DEC with different probability values. So this is a very powerful and efficient model. So, and the third way of expanding the Omax paradigm will be in trying not only to have a scenario, but and having a reactive model, but having both together, that is react to the context, and as a reaction to the context, generate short-term or medium-term scenarios that will be coherent and that will be anticipation of the context, and that will drive the improvisation. So here, for instance, you have a machine learning mechanism that is recognizing chords and devising a prediction for the 4 next chords and feed the improvisation model. So the improvisation will improvise under the constraint of this local scenario. So we're going to have local scenario. Here's a short video where you can see all this explained, and it is self-explained. I jumped a bit later. Okay, so as I said, as a difference with the Omax system, we have this we have the scheme listen, learn, interact. But now we have also the idea that the user can input some scenarios which will generate a symbolic signal to the interaction agent, who's going to take this symbolic signal in account at the same level than the symbolic signal coming from the real-time environment, or one arrow is missing, or from the actually it is this arrow, or from the memory model that has been learned either offline or online. But then you have this additional arrow here that says that the interaction module can even, depending on all this information, generate new local scenarios that is going to apply. It's going to apply for the short future that is coming. And all this can be reconsidered at any time and recomputed, and it's an adaptive process that will adapt to the musical situation. So what we have now are these 4 graphs where the Omax model is actually the position at the 0, that is, it has no planning, it has no reactivity. And we have devised several systems that gives a lot of reactivity, that gives a lot of planning, and we're trying to find the interesting regions where you have both interactivity and planning, and including this situation with the short-term scenarios where the system is actually generating its own planning, not only considering a given composition, but generating its own planning depending on the real-time machine learning from the sound situation. So here are a few examples where the short-term scenario are used using the DC2 system. Here you're gonna see Hervé Célin, pianist, actually improvising with a video of Diana Reeves that comes from the Montreux, it's a historical video from the Montreux Jazz Festival. And the video is really reconstructed and re-improvised depending on what the pianist does. we're going to see two other video with the live interaction between saxophonist Remy Fox and saxophonist Steve Lehman with the same system. And here I'll show you the system for extracting automatically from the learning data all the interesting audio descriptors that are going to be used in order to make a cluster analysis, build a representation space where they will be matched to what's coming from the input in order to be able to match the input with harmonic information, textural information, timbral information, time information, and generating the scenarios. Clearly here in the second part of this video that the musician, the live musician, was guiding the system melodically and harmonically, and the system was generating micro scenarios linked to predefined specification, but that are actualized depending on the musician's playing. And at the beginning of the sequence, you could hear that the interaction was really more textural and timbral. Here's another piece with Steve Lehman, where you will see first a rhythmic percussive interaction, and at the end, a harmonic and timbral and textural interaction that really goes toward this compositional genre that we call here spectral music. Okay, so this DICE2 project just ended and has given rise to many public manifestation, concerts, festival. We're also organizing the Improtech Festival, which brings together people reflecting on improvisation and machine intelligence and machine musical intelligence. The previous one was held in Athens, and we're trying to organize the next one in Tokyo. So this project just ended, and we have begun two new important projects. First one is Merci. It's a national research agency grant, so it's a continuation of DC2, but now we want to introduce the physical instruments. So we're collaborating with a company called High Vibe, who has designed musical instruments such as the guitar, you can see here, equipped with active acoustics control. That is, you have sensors and actuators inside the instruments that can control physically the behavior of the instruments. And we want to put the machine intelligence, the musical machine intelligence, machine musicianship inside the instrument, so the instrument will be able to play along with the musician. So here are examples where you just have the active acoustic control, but later on we will have all the musical stuff that you heard in the previous slides. And the next important project that is going to begin on January 2021 is the IRC, European Research Council project. It's a grant, it's an advanced IRC grant that I just got, and which will allow us to pursue all this research for 5 years. And now we really want to put the idea of co-creativity in the center, and to try to understand what is a cyber-human interaction. So just to sum up the central idea in the project, we think that co-creativity is not a state, it's an emerging phenomenon, an emerging dynamics that results from complex interaction between actors. So it cannot be understood by considering just each agent's production in separation. Doesn't work because it's a complex system. And it neutralizes the usual and tedious reflection about what is artificial creativity, can artificial creativity exist, because we're no more into this question. We're studying something that doesn't exist as a state, that is not contained in the computer or in the human. It's the emergence of an interaction between the computer and the human. So, this co-creativity is going to appear when you have emergence of cohesive or constructing joint behaviors that are not reducible to individual processes. And you will have the apparition of non-linear regimes of events and structure formation of forms that will lead to co-evolutions of form. You could hear such things in the examples previously, but now we want to be able to control this in a much more precise way. So this will appear when you have two conditions. You have cross-learning processes between the agents, the human and the artificial. And so you have complex feedback loops that create reinforcement mechanism. That is, the machine is listening to the human, so it learns, so it plays, but the human is listening to the machine, so it changes the way the human plays, etc., and you will have reinforcement mechanism. So as cyber-physical systems were used to create interaction continuity between the digital and the physical world using sensors, actuators, etc., now we propose the term cyber-human for systems that will create this continuity and interactive synergy between the model, the digital and the software models, and human creativity. And additionally, we want to put the instrument, the physical instrument, into the loop, so to create actual embodiment through this creative instrument, thus creating actually a mixed reality based on this co-creativity scheme. So this is the end of my talk, and we kept a few minutes for just a few questions. So Dorian, if you're around.
Thank you, Gérard. Very interesting talk. I very much agree that co-creativity is one of the most important things we can work towards in music generation, and your work definitely reflects that. So we have a question or some comments on Slack. So, for instance, Nato Tale also says, super exciting talk. When will the DICI2 library be compatible with Python 3.7? It says coming soon on GitHub.
Yep,
do you have
it is available on GitHub. Unfortunately, I didn't write the links, but it's easy. You just find DICI2 and you will find the library. It's going to be very soon Python 3.
Okay.
And also, also a brand new version of Omax, the reactive system, already written in Python 3, is available under the same GitHub repository.
All right, thank you. Stefano Colonare is looking at the GitHub right now, and he says, so the Python module is the backend, and you use Max for the front end, or?
Exactly.
All right. All right, any other questions? Don't seem to be any other questions on Slack at the moment.
So it's perfect that we're exactly in time.
Yes, but thank you very much again for your very inspiring talk.
Thank you
I
so
very
much for the
enjoyed it.
invitation, and thank you for monitoring the talk.
Yes, my pleasure. Thank you.